Hello everyone. In this video, we are going to show you how to install and configure Containerlab in macOS. So what is the benefit of using Containerlab? As you already know, GNS3 or if you use any CML based Cisco topology, we need a vendor specific OS and most of the time it's not free. In such scenario, Containerlab can help us to build our own topology in home lab, and this setup is entirely open source and free. Containerlab is not a runtime. It is kind of like we can consider as an orchestrator, and it is like a Go binary that we run. So how the topology here look like? We have a Mac OS, and our Mac OS is Apple Silicon based, which is ARM64, and then we'll use a hypervisor or a VM manager, which is OrbStack. In that OrbStack, we're going to use a VM. We are using Ubuntu here. Then inside the Ubuntu machine, we are going to install the Docker, and this Docker container will help us to instantiate different nodes. Say for example, we are using node FRR, free range routing open source routing suite. That is actually a software that speaks BGP, OSPF, ISIS, and multicast protocol like Beam. So think of it as a routing brain that vendors like Cisco or Juniper wrap in their own OS. So FRR is that brain, standalone and free. We can spin up those FRR processes as a container using Docker, and Containerlab is the CLI which will help us to make the virtual connections between the containers. In order to go a little bit more about how the FRR actually work, it actually came up with a Zebra. Zebra is kind of like a routing information based manager. Say for example, BGP D process or OSPF D process or static D process has their own routing table, and those routing table going to be forwarded to the Zebra, and Zebra it will choose the best route and then it will fed into the Linux kernel forwarding information base. So let's go ahead and try to see we can install this Containerlab in our Mac OS. All the necessary commands and supporting documents I'm going to upload in my GitHub repository, and it will be available in the YouTube video description. So I have already Homebrew installed in my local Mac OS. Now I'm going ahead and install the OrbStack. At this point, OrbStack has been successfully installed. Now we will go ahead and install Ubuntu machine on that OrbStack. Then it will pop up to configure your Linux machine in that OrbStack VM manager. So I'm going ahead and creating that Ubuntu machines. At this point, as you can say, it's already up and running. Now let's go ahead and try to go inside virtual machines. At this moment, I'm inside the VM machines. Let's try to install some packages which we need for this Containerlab to be installed. Now we are going to install the Docker engine. So at this moment, Docker has been successfully installed. Now let's go ahead and install the Containerlab. So as you can see, Containerlab support has been successfully installed in the VM. Now let's try to exit it out and try to log in again to the VM. And let's try to see the Containerlab version. It's successfully showing Containerlab version. And let's try to see the architecture type. Here, as you can see, it is trying to print out the architecture type is ARM64. We have downloaded a new images for FRR routing, which we are going to use for container D images. It's showing the version is 10.4.1. Now, I have already some topology file, which is it's used to build up the topologies, and it used in the format of YAML. Let's see what is there in my current working directory. So as you can see, I have two lab here. One is hello, and another one is like we are trying to bringing up one BGP topology. So let's go ahead and try to work with the lab 1 here. For now, I am going to inside the lab 1, so which is 01 hello. So let's go inside and let's see. We have that YAML file and the configuration for two routers, R1 and R2. If you see the YAML file format, let's go ahead, take a look. So this is my topology name, hello, and we are using kind of Linux. It's a default topology type, and in the notes we defining R1 and we are using FRR image which we downloaded. Then this is the some configurations that we are using for this configuration for R1. Similarly, the same configuration is applicable for R2, and the link, the connectivity between R1 and R2 is via Ethernet 1 connections. So now let's go ahead and deploy this topology. So as you can see, successfully it deployed this entire topology and it is up and running. So if we want to see some show interface command or ping command, so let's go ahead and try to run this command. So this is the way that we can check interface from router R1. It has a loopback 0 IP, it has Ethernet 1 and Ethernet 2 IPs. Then we can go ahead and ping from router 1 to router 2. So let's see if the ping is working or not. As you can see, the ping is successfully working. In order to clean up this topology, we can do this next command. This way we actually clean up and destroy our lab 1. Now let's go ahead and try to work on the next lab. So the next lab is BGP. We are going to BGP, going to deploy that particular lab topology. It is trying to download a particular image because in this topology we have host as well. It is kind of a spine leaf topology. So for the host image, it is using some particular image version and it was trying to download that image as well. So when the topology came up, it actually came up with corresponding BGP configuration as well. So let's see from leaf 1 what are the topology look like or BGP configuration look like. So it is actually showing all the BGP configuration, and as you can see that it is receiving prefix from its neighbor. So we can execute some other BGP commands and we can do the pings. So, and if you want to go ahead and try to log in to the device directly, so you can log in and you can get the feeling of actual Cisco based CLI format. Now this topology is up and running. Now if I would like to see how to visualize the topology, so we can use the Containerlab graph command. This will help us to visualize the current topology. So let's see and go ahead and run this command. So now if I go to this particular IP address, you can see currently actual topology. So we just need to do the rearrangement here. Spine 1, spine 2, then leaf 1, then leaf 2, then host 2. So this is our current working topology. So let's go ahead and cancel this. Here I have given some cheat sheet command which will help us to deploy the topology using Containerlab. I hope this information is helpful to you.